Now we come to see what is the result that we derive so far. Now we are going to present to you the Finetti surprise, an important theorem. I will ignore technicalities, you can find continuity, completeness, you can find them in the book. I focus on the main ideas. The Finetti, he showed, he's Italian, around 1930, he showed that three statements are equivalent, and equivalent means they are logically equivalent. One is true if and only if the other is true. There are different ways of saying the same thing. First statement says expected value holds, so you should choose these subjective probabilities, etc. Second statement says satisfy monotonicity, transitivity, additivity. So that's the advice of the advisor. Third statement says no arbitrage. So the Finetti proved just logic, mathematics, nothing philosophy or whatever interpretation, just mathematical statements. Is no debate about. These three statements are equivalent. As regards the proof that they are equivalent, in fact, I only showed really that statement 2 implies statement 3. Maybe you remember when I presented arbitrage or that book, I told you this is a very particular way of violating the advice of the advisor, those preference conditions. And I explained that to you. So indeed, 2 implies 3. If you follow the advice of your advisor, there can be no arbitrage. I then said it's a very particular way, but here you see, in a way, it's the only way. It's equivalent. Whenever you violate one of those preference conditions, you must be violating arbitrage. So in a way, it's the only way to violate these conditions. Always, if these are violated, there is some arbitrage. They are equivalent. They are also equivalent to expected value maximization. Now, this theorem has many, many implications. To start with, it means rehabilitation of our advisor. Because for the first advice that our advisor gave was, you should do expected value maximization. We said that's a lousy advice, no good. Then he said we should satisfy these 3 conditions. We studied them, discussed them, and found them useful. But now we see those 2 advices are identical. Expected value maximization is equivalent to satisfying these conditions. So the first advice that he gave us was the same as the second advice. His first advice has now been justified through the second way. So that's one of the many implications of this theorem. Often people say this theorem provides an operationalization. I already told you I always want to do that in this course. This is an operationalization of expected value maximization. Because if you just look at the claim that expected value holds, you can call that a theoretical statement. You're saying subjective probabilities, and it's a bit of fake concept. What are these things? You don't really know. And you put up a formula, and this describes decision making. It's quite hard to understand what the empirical meaning of it is. What is the meaning of probabilities? Why should you multiply? It's all not very clear. The second statement is all conditions that are directly empirically meaningful. Because we are playing the economics game, good decisions, that's what we want. All these conditions are directly in terms of decisions. They speak about decisions. They have direct empirical meaning. So this statement 2 is a sort of the empirical translation of statement 1. This vague theoretical statement is valid if and only if these empirical conditions hold true. So that sometimes people call operationalization. You can empirically verify expected value maximization if and only if you can verify these conditions. You can falsify expected value if and only if you can falsify these conditions. So they capture the empirical meaning of statement 1. That's what people often use the term operationalization in general in empirical context. And if it concerns operationalization of a theoretical decision model, then people call that a preference foundation. So here we have a preference foundation. Well, preference foundations are very useful, and I'm going to spend some more time to explain to you. In a normative context, which was the main interest of the Finetti wanted to convince people that using subjective probabilities is a rational thing to do. And there were philosophers, I felt, libraries discussing the different meanings of probability. Many people say subjective probability is not a useful concept. It's a silly concept. How can you even think about such a concept? the main thing he wanted to do is to convince people that it is rational to use these concepts. And he bypassed everything about religion, philosophy, whatever. He did it in a mathematical way. He told people, don't you think these are reasonable conditions to satisfy? And people agreed with it. Well, then he proved, just as a matter of mathematics, well, if you accept that a rational person satisfies these conditions, you must do expected value maximization. You must be using subjective probabilities and so on. That also means once you have accepted that these are good conditions, you cannot escape from using this concept of subjective probability. You can't, there's no, sometimes they say there is no argument with God and logic, but the Finetti is using logic here. If you agree that these are good, these are good preference conditions, then you must be using subjective probabilities. That was the primary purpose of the Finetti, to prove, normatively speaking, the goodness of a model. You could also use such a theorem to convince people normatively that a model should not be used. For instance, if you can convince people that additivity is not a good condition, then you can use this theorem and say, that means that expected value cannot hold. Additivity violates, expected value violated. And in fact, we have already seen examples. We saw this finance example. If there are extreme outcomes, big outcomes involved, then additivity is not a reasonable condition. So then you should not do expected value maximization. You should do expected value maximization only if the stakes are moderate. So normatively speaking, you can use such a theorem for justification, also for criticism. Also empirically, such a theorem is useful. If you want to claim empirically that the model holds, you can verify or falsify a model if and only if you can verify or falsify these preference conditions. And verifying such a model is a bit difficult, but they are directly in terms of preference. So you know directly what they mean empirically. You can directly test, verify, falsify these conditions. So that's how you can use such a theorem empirically, descriptively. So de Finetti, he wanted to convince people that using subjective probabilities is a sensible thing to do. He was, and this is, for instance, statistics important. In what people call classical statistics by Neyman Pearson, this was developed quite to avoid the use of subjective probabilities. Neyman Pearson and many people did not like subjective probabilities, therefore developed statistical techniques that avoid them. But if you believe these, I do it, I think these are rational conditions, and if you apply them in the context of statistics, you will see that you have to do Bayesian statistics, you have to use these subjective probabilities or things equivalent to that. So that was a big interest of the Finetti, to show that the Bayesian approach to statistics is better than the classical approach. And surely I was convinced, and many people with him. And that's already quite some implication. The theorem is also central in finance. In finance, no arbitrage, actually that is very central. What I present you in no arbitrage is a version of the no arbitrage condition of finance, in fact. That means you must do expected value to this as if risk-neutral pricing. That's one of the most fundamental results in finance. So in fact, it was de Finetti who provided that basis to finance. So that's yet another application. And this theorem also shows you, for instance, you can say, if you want to claim that, for instance, I claim that people are too risk averse, you can say, how can you say? In the end, only God can know. You know, what is good for a person, you must know everything in life before you can judge on that. Nobody can judge on that. Still, with these techniques of decision theory, we can quite easily, using these preference conditions, we compare one decision, we look at the combination of decisions, and if we see additivity is violated, we already know for sure this person is somehow not really optimizing what is good for him. And if you study a bit more, I will do it later in this course, we'll study all kind of models to explain all kind of violations of rationality conditions, then we get better insights. And then that taught me that people are usually too risk averse. So it turns out to be possible to say such things, even if you don't have the divine insights. It can be done using preference conditions. A nice application is also for insurance, for instance. I claim that if you believe this theorem, which I do, and I recommend the same to you, you should not insure small things like maybe bike or smartphone losses that can happen to you, but that you can bear. You can bear the costs, they don't change your life. Such things you should not insure. I claim that follows from this theorem. Maybe you can stop the video for a moment and try to think if you can understand why that is so, and make up your mind and then come back. Okay, I assume you thought about it, and it's a bit of a tricky reasoning maybe, but now I'll tell you why that is so. First of all, we're talking now about, as I said, insurance of losses that you can bear. So small losses, things that do not change your life, moderate money amounts like losing your bike, things like that. In that case, I think these preference conditions with additivity and so on are reasonable. I think you should do expected value maximization. Then the big question is, how should you choose the probabilities? What are the best probabilities? You want to take the best probabilities that you can. And in fact, you need not think very much about it, because it's easy to understand. The insurance company has very good statistics. They know very good what the probabilities are. So their probabilities are very good. Well, the insurance companies are making money. The expected value of the insurances that they provide is positive for them. That means with their very good probabilities. Otherwise, they would go broke. So from that, you can already understand that the insurance that they offer you must have a negative expected value for you. That way, you know you should not do it. And in many, Holland is one of the most insured countries in the world, too much. People are insuring way too many things. I think there's a big loss. Well, your insurance is a good thing for society when it's big damages. Like if you get impaired health for the rest of your life, your house burns down, very big damages that change your life, then insurance is a very good thing. I should let that be understood. But insuring all these small things like your smartphone and bike is just a waste. It's inefficiency in society. And I guess that most people in Holland, they lose 0.5% of their income all their life long by all these silly insurances. So then if you really believe this theorem, if you pay attention to the behavioral approach to decision making, you can learn that you should not be so risky. People are too risk averse, for instance, with insurances. Don't do that. Cancel all these small maybe that's homework for next week. You should have canceled all your small insurances all the rest of your life. That will increase your income by 0.5%. You're paying more premium than you get back from these insurances. You're just losing from it. And I hope that I'm coming to the end of this first meeting, the recordings of it. I hope that this shows you a bit that the behavioral approach is a useful approach. You increase your income the rest of your life by 0.5% just by understanding these things. That's already one of the many things that you can learn from it. So I hope that you will be interested in it and many more things. In the next meetings, we will investigate in more detail how come people are violating these preference conditions, these rationality conditions, exactly how and where. So how and where human decision-making can be improved. And one we already saw, drop all those small insurances. So with that, I'm ending this first meeting, the recordings of it, and we'll continue with it in the next meeting, maybe next week.